Actually, I accidentally stopped the video. Anyway, so now how do you connect an ammeter? Right, 1 milliampere ammeter or less would be very unusual because it's very hard to detect. Right, so you want to amplify the ammeter in this case. I mean, you want something that is to amplify the current, right? So we implement a resistors over here, which is parallel to the ammeter. So what is this gonna do? Right, so hold on. Remember V is equals to IR in this case, right? And then the current flowing through this this resistor, this is resistor and this is resistor. I mean resistance of the ammeter. Okay. The current flowing through this one is different. So maybe you can call it IX plus IA. You have your total resistance. Okay, if it's in parallel, the current have to be added out. And one significant difference, keynotes you take note is that and x divided by x plus 500. Okay, so this is 500 ammeter. If you were to find this current, you're actually finding the current of this ammeter, right? Okay. Instead of finding this, okay, so this is the current divider rule. Adding voltage or whatever now. And then okay, I don't know where I stopped. I did a long time to calculate. Anyway, so if your Rx in this case is 5 by 05, okay, if this is x 5 by 05, right? So let's sub in over here. So 5 by 05 divided by 5 by 05 plus 500 is actually 505 by 05 times your current, right? So this thing, if you were to multiply with the current, you will get the amount of current flowing through this ammeter over here. Alright, this is how the formula works lah. You're taking the X resistance divided by the overall, multiplied by the initial current over here. You'll get the current over here. So this is the opposite. Instead of, getting X and then divided by this one and then times, you'll get this. It's not lah. Okay. I think hopefully you understand what I mean. So if I were to do that, okay, let me hold on. So 505 divided by 505.05, I'll get 0.009. Okay, and then if I were to multiply with my input voltage, input current of 100 milliamps, which is from here. Okay, if I were to do that, let's take a look. So 100 milliamps is actually what is it? Times 10 to the negative 3, right? So in this case it's 1, 2, 3, so it's like 0.1. Okay, so 100 milliamp is actually 0.1. So if I were to multiply by 0.1, divided, shit. So I divide first. Let's get back to this, okay? So in this case, because V is equals to IR, right? So I is equals to V over R. Correct? I don't know what I'm doing, okay? sorry, I'm damn tired. So in this case, okay. So I took 5.05 divided by 505.05, I have this value over here. And if I were to multiply with the input current of 100 milliamp, which is 0.1, I should show you just now, right? If I were to multiply by 0.1, I'll have 0.0000. So in this case, it's 1, 2, 3. Okay. 1, 2, 3, which is so it's 1, 2, 3, which is 0.9, right? Which is 0.9 milliampere. Okay, which is in this sense, if you round off, is actually 1 milliamp. Okay, so if your resistor is, so as you can see, this resistor is actually a very low let's say if your ampere is high, if your ampere is small, you're gonna have a resistor that is small. Okay? You're gonna have a resistor that is big. Okay, 5.05. If your ampere is small. If your ampere increase, okay, so so if your ampere increase, in this case is from milliamp to 10 amp to 100 amp, your resistance has gonna be decrease. Okay, has gonna decrease. So you can see it's going smaller and smaller, way down smaller. Alright, and then what does this mean? Okay, this means that if you want, because you want an ampere that is 1 milliamp, that is always 1 milliamp, right? If a different type of ampere comes in, you're going to ensure that the different you're going to ensure that the milliamp over here is always the constant. So if this milliamp is going to increase, you're going to have a resistors that are going to decrease in order to suit the system. Why? Is because V is equals to IR, and then V over R is equals to I. So if your current increases, definitely if the voltage is constant, right? If the current increase, your resistance is gonna decrease in order to keep the voltage constant, right? In other words, this formula, okay? In other this formula, this is R. So if your current increase, your resistance is gonna decrease in order to keep this thing constant. So in another sense, you're gonna, yeah, I think you get what I mean already. So and in fact this is not voltage lah. This is actually the current. This is how you connect your ammeter, in the sense that you could have how do I say, you could have an milliamp that does not exceed 1 milliamp. Because if you were to remember, you actually, this is the range 0 to 100, which is actually from some values to 1 milliamp, okay? So this is why the milliamp is actually the highest, as it does not exceed the full scale, which is 1 milliamp in this instance. Okay, so I hope I didn't confuse you anything, because I actually confused myself a lot. Yeah, and then so however, if you were to connect in this manner, you would have some problems. Okay, this is the initial problem. I mean, this is the initial form. If you have a 2 volt DC, okay, and then you have some currents flowing in this direction, some ohms. And if you were to apply an ammeter over here, if you put ammeter, you have to put in series, alright? So you put a ammeter over here. What you did is actually changing the current. Okay, so in this case 666.7, you change it to 471.43. It's because the ammeter itself has a certain resistance of 0.5 ohm. So in this case, you are gonna change the amount of resistance. So when you're measuring this 3 ohm, you are measuring 571.43 ampere. Is because of the ammeter's resistance. So in this case, you're gonna share the resistance with the other party lah, in a sense. So so you're sharing your ampere with the other party. In order to be exact lah, okay. In order to be exact, if you were to put ammeter over here, this whole line has the current of 571.43. Okay. So this is the thing that he's talking about. And change the value over here. Okay. From 666.7 to this value. And nonetheless, if you were to decrease the ampere from this to this, definitely you're going to increase some ampere. I don't know why it's still 1.33. I think he did, I don't know, I may be wrong, but it should be increased also. So this thing should be also another values, should be a higher current in this case. Okay, so if you were to implement a ammeter, okay, you're gonna change the whole values. Okay, you're gonna affect the whole system. So ideally, okay, so the purpose of this is to say that ideally you need an ammeter that is resistance equals to 0 ohm. so that you stay with a 3 ohm and 1.5 ohm in this scenario. So if you put ammeter over here, there is no resistance. There only be calculations of 3 ohm and 1.5 ohm. That's all. So this is the key thing. So if they ask you to explain this, you're gonna draw this thing out, and then you explain the relationship. So now we talk about so I clear away the ammeter problem. So let's talk about voltage in the next video. So see you.